We are taught that outer space is an absolute sterile vacuum. Step outside a spacecraft without a helmet, and the complete absence of atmospheric pressure will kill you in seconds. It is the ultimate empty room. That emptiness makes smelling anything out there a biological impossibility. Human olfaction requires a breathable atmosphere, a physical medium of gases to carry microscopic particles directly into the receptors inside our noses. Yet this has been the consistent experience of NASA astronauts. Fresh from spacewalks, crews return to their ships, take off their helmets, and find a distinct, pungent odor clinging to their gear. They describe an aggressive aroma, the scent of seared steak, the sharp tang of hot metal, and acrid fumes of industrial welding. This creates a direct contradiction in physics. Smelling welding fumes in a total vacuum violates the established rules of both human biology and atmospheric science. The physical isolation required to survive a spacewalk is absolute. This photograph of a tethered astronaut shows the multi-layered suit that creates an impenetrable, pressurized barrier against the outside environment. Crews never experience this metallic scent while they are actually floating outside. The aroma only manifests once the airlock is sealed and they have returned to the pressurized module. The scent doesn't originate from the suit's internal air supply, and it cannot exist in the vacuum itself. Solving the discrepancy requires looking past human biology and toward the molecular chemistry occurring on the exterior of the suit. If we zoom out from Earth's immediate orbit, the vast universe reveals itself as a highly chaotic, destructive environment. This photograph captures the Crab Nebula, the remnants of a dying star. When these stars collapse and explode, they scatter immense quantities of complex elements across light years. One of the most abundant materials forged in these stellar deaths is a complex carbon-based molecule called a polycyclic aromatic hydrocarbon, or PAH. These diagrams visualize how PAHs behave in deep space. They drift through the vacuum as microscopic suspended carbon dust, remaining completely dormant in the cold. Outer space functions as a massive, invisible reservoir of suspended chemicals, holding these particles in a dormant state until they find a reactive environment. When an astronaut maneuvers outside the International Space Station, they are physically swimming through this field of ancient suspended particles. Microscopic cross-sections demonstrate the interaction. As the astronaut maneuvers, these carbon-based molecules physically accumulate and adhere to the woven exterior fabrics and exposed metal of the suit. While outside the ship, these particles remain inert. Without oxygen to fuel a chemical reaction, the carbon dust stays entirely odorless. The spacesuit becomes a carrier. The astronaut finishes their work and heads back inside, unknowingly bringing millions of unreacted stellar molecules into the airlock. The spacewalk concludes as the astronaut pulls into the airlock and the outer hatch locks shut. As the airlock repressurizes, life support systems rapidly pump high-density oxygen back into the confined chamber to recreate Earth's atmosphere. The sudden change in environment triggers a reaction. The moment those dormant PAHs on the suit are hit with a high concentration of oxygen, they oxidize. This immediate oxidation breaks the molecular bonds of the carbon dust, generating a sharp byproduct concentrated with ozone. Once the airlock matches the ship's internal pressure and the astronaut removes their helmet, these newly created airborne compounds reach their olfactory receptors. The sharp tang reported by crews is the scent of star ash combusting in a high-oxygen environment. A real-time chemical reaction triggered the moment they step back inside. The seared steak and hot metal reported by astronauts are the direct sensory evidence of stellar remnants colliding with a high-pressure atmosphere. These molecular interactions bring the chemistry of distant star deaths directly to a human observer. We have spent decades viewing space as a sterile environment. The physical evidence proves otherwise. When we look past the myth of the empty void, we see the cosmos for what it is, an active, volatile chemical kitchen. Our spacecraft and our explorers are physically swimming through the suspended remnants of cosmic destruction. The universe is a tangible environment. It leaves the harsh, metallic trace of its history on anything that dares to explore it.